Welcome to the Cyber Life Podcast, where we help you learn cybersecurity best practices, give you a weekly update on the latest cybersecurity news, and share valuable career advice. Hey everyone, it's Ken. Thanks so much for listening today. In this episode, you're going to hear from Katoria Henry. Katoria is a multi-award-winning cloud security and technical resilience expert. She holds a graduate degree in cybersecurity along with multiple industry certifications. She also volunteers her time with several organizations. Now, I want to put a disclaimer here that just like all of our guests, anything shared on this podcast is strictly the personal opinion and thoughts and education coming from Katoria. It does not reflect her employer or any of the organizations that she volunteers or is otherwise affiliated with. Now, I affectionately call Katoria the NIST Barbie because she's such an expert in all the NIST documentation. So if you're listening to this episode, I will have one ask of you. Will you please write a letter to Mattel, who owns the Barbie intellectual property or the series of Barbie stuff, because the goal is to try to get Katoria made into an actual cybersecurity doll. So we call Katoria NIST Barbie. Let's all write a letter to Mattel to try to get them to actually create a doll for cybersecurity and name it Katoria. So today, Katoria is going to talk with us a bit about cloud security architecture best practices, and really the goal is to help you walk away understanding how to build things securely from the ground up. So welcome, Katoria, to the show. Glad to have you on. Always a pleasure to chat with you. So today we're going to talk about cloud resilience, and there's probably some people out there that are like, what in the heck is that? So do you mind just kind of giving a brief overview of what exactly is cloud resilience? What does it mean when we say that?
It's a lot of things, right? It really depends on, let's start here. For me, if I'm talking to an organization or I'm working with you regarding like cloud migration, or you're trying to, let's say, rebuild existing architectures that you have, it's number one, understanding, are you going with a monolithic approach or are you using, a microservice architecture? I think that's the first thing that you have to consider when you decide upon how resilient you intend for your, services or applications to be. We know that, most organizations, those that still have, I want to say, that legacy mindset, they tend to favor the monolithic architecture. Why? Because you can quickly deploy, your code, right? But you have to think about this. Everything is shared, right? You usually have like a single server or, an individual cluster or something like that. So you're not going to automatically have like resiliency built in. You think about a microservice architecture, which is, I want to say, more of like the modern approach, right? Loosely coupled, right? Services can be independently developed, deployed. You have more scaling capabilities, right? Then you have those APIs or messaging queues that are usually used for communication, with those architectures. I think that's the first thing that you have to really understand and define before you can truly start thinking about or planning for, resiliency or high availability, essentially. That's the way that I would typically approach it. But when you talk about resiliency and what exactly, that means, let's say, you have multiple services and they all need to basically, if there were like a service disruption or something like that, these services have a predefined like RTO and they have RPOs in place, right? If these services have to scale and come back up within, 2 or 3 hours or something like that, then you're thinking about having true resiliency in place, technical resilience, for that matter, for these services, right? It's not just about resiliency. You also have to consider security and availability at the same exact time, right? That you're designing these things. So designing things with failure in mind is something that really comes to the forefront of when you're talking about true resilience, right? You can't design with failure in mind without having those pre-identified or predefined failure scenarios in place. Think about performance bottlenecks, right? think about human errors. That's something that no one generally considers, which is very, very weird to me, right? You have to think about those misconfigurations, incorrect deployments, right? The change processes that you all have in place, things like that. These are all factors that contribute to and should be considered when you're thinking about how you intend to build a service to remain resilient and highly available. Vendor specific issues is something that you also should consider with the failure scenarios. Just a lot of things. I can keep going and going, Ken, but architecture, it really goes back to the architecture and really defining what you want. Monolithic, microservice, distributed architecture is really something that you should consider, right? Having that redundant architecture that's literally spread across, multiple availability zones. You hear a lot of, oh, is the service spread across 3 AZs, right? Or is it spread across multiple regions, right? You want to minimize the impact of failures that you have within a given location to ensure that you have that fault tolerance in place. Again, man, I can keep going on about what it means to be resilient, but this is just like bare bones things that you should absolutely consider when you're designing, right? This is before you truly build something out. You're literally jotting down ideas at this point in time.
So you kind of mentioned some of the challenges already, but like if we just take a view of both the legacy architecture, which a good amount of organizations unfortunately are still doing when they migrate to the cloud, as well as a little more modern or best practices, if you will, with the microservices. What are some of those and you don't have to do like all the most common challenges, but like maybe just pick like what are the top 2 or 3 challenges based on your experience working with a variety of organizations through a variety of your roles over the years, from both the legacy side. So what are maybe 2 to 3 the most common challenges you see that they're facing when they're trying to implement technical resilience in the cloud, as well as how can they overcome those? And then conversely, for the more modern approach to cloud architecture, what are maybe the top 2 or 3 challenges you can think of, as well as how can those organizations overcome those?
Absolutely. That's an excellent question. I'd say, for those that are still, stuck, I want to say, in the 1800s, right, with their architecture and those legacy systems, in most scenarios, from my experience, they really are still stuck on that monolithic approach, right? Things that you probably more than likely will absolutely not get. When you think about those architectures, you want top 3 things. Off the top of my head, I'm going to talk about maybe release management is a problem, right? You're not going to have, fast iterations and deployments of things because, again, it's like everything is just a single tone. You have a single server and all of the services, right, that are basically tightly coupled. They're not loosely coupled like a microservice. It's literally deployed as a single entity. And so if something were to happen with that monolithic architecture, right, for a certain application, then it goes down. Everything goes down that you've essentially built because you have that tightly coupled unit in place. You're sharing the same thing across the architecture. You're more than likely not going to have any sort of scalability in place. The entire application is probably not going to scale because all of the components are using the same code base, which means if I have something configured and let's just say we're spinning up, a pod or something like that, and it has one replica, right? It's not going to scale or anything like that because of how you've already configured that, that pod within your Kubernetes cluster, essentially, right? So scalability is definitely going to be an issue. Even for the components, right? If your components need additional resources and whatnot, because you don't have scalability and elasticity in place, those things are just not going to happen because there's no on demand. Everything is just focused on a single pipeline because you have that tightly coupledness, I'm going to say, together. If you think about microservices, right? things that work in their favor, but things that could also be problematic. If you're working on the same code base, something that could become problematic with this, even though this is something that is very helpful and it's beneficial because you have team scalability when you think about microservices. But if someone on your team were to make any sort of modification to that code, and let's just say you don't have like branch protection rules or anything in place, then guess what? Your code base has essentially been modified, and it could disrupt the applications that are in that production environment and things of that nature. So even though you have team scalability in place, which would essentially improve overall, parallel development and things of that nature, you still could have some sort of disruption to the applications that are currently in production if you're allowing individuals to make modifications to that shared code base, and no one's really validating and checking that, hey, this person actually submitted a PR and that same exact person approved, their PR. And when I refer to PR, I'm talking about, a pull request, right? Think about fault isolation as well for microservices, right? Typically speaking, right, because you have a microservice architecture, if a service fails within that architecture, it doesn't necessarily mean that the entire application is going to be impacted. So that's one thing, right? But at the same time, let's just say that's a mission critical service that is actually failing. And that service is considered an upstream dependency on some of the lower level services within that architecture. Then guess what? You have a service that is essentially failing all around, because even though that one essential service is failing, because the other services that are at a lower level depend on that service, they would essentially, be impacted. So fault isolation is good for microservice architecture. It's a benefit, but you also have to consider your dependencies when you're designing these things to make sure that, hey, if you're building these things out, understanding the tiering levels of the services, understanding all of the upstream dependencies, making sure that you have a similar or a like service within that microservice architecture, so that if one component were to actually go down, then you have, I want to say, a spinoff of that service that would still essentially be available to the other services that may actually depend on it, so that everything is not impacted, if there were to be some sort of service disruption to take place.
Are there any like real world examples you can think of where you've and if it's related to like a client you've worked with, obviously obfuscate whatever, but if we don't want them calling us with complaints, but any real world situations you can think of with actual resiliency failure in cloud environments that maybe has made the news or something like that, and then kind of your perspective, if you can, your perspective on what are some of the lessons that the listeners could take away from that.
Absolutely. I have to sneeze, so I'm trying not to let it out. What I call out, and I think I talked about this before a few years ago on LinkedIn, kind of got a lot of backlash about this, but it was so interesting. The Capital One issue that took place with their AF, right? That firewall that they have with AWS. When news broke, right, it was all about, AWS's fault. I can't believe that they would allow this to take place, but once the story was fully broken down and Capital One essentially, took ownership of the way that their environment was configured, I think everyone really started to think about the way that they designed their network and their connection issues. Or not issues, but their network and their connections, right? If you're going to be leveraging a service from a cloud service provider, first and foremost, you need to understand what exactly comes pre-configured versus what you, as the customer, would be essentially responsible for configuring. You have to think about all of the potential points of failure when you're using, these external services for your internal environments. And you can't always blame the cloud service provider when something happens, because a lot of times these are, configuration issues that are often overlooked. And you have a lot of, organizations that like to use services and products, out of the box. And that's essentially the absolute worst approach that you can take when you're designing your architectures. Granted, there are some pretty solid configurations that come with the services that you use from these cloud service providers, or even from, just third party, maybe software tools and whatnot. But at the same time, you have to think about how resilient you actually want to design that architecture. And I think, having a resilient network architecture is key. And that is something that essentially was not in place for Capital One, which is why they experienced that issue, with their firewalls. It was just really poor configuration. And, we just used this out of the box. We figured that everything was, correct. If you are an organization and you have your own internal security protocols, your own internal security standards, those should absolutely be considered when you're designing your architectures, right? That baseline configuration is key to making sure that these things are in place so that you'd have something to mitigate, any future risk if they were to basically come to the forefront. That's an example that I think really kind of open a lot of organizations' eyes and understanding that, okay, I can't use this right out of the box. I want to, because I don't have time to configure this the way that it should be properly configured, but it's not actually a best security practice to do that. And I think that incident really opened up, a lot of organizations' eyes in the way that they actually, design their architectures and the services that they use. Definitely always take a deep dive and look at the baseline configuration of those services that are in place.
So how can organizations actually monitor and manage the resilience to ensure that, let's say, for example, they're not using, or they are using default configurations for a lot of the services. How can they actually monitor that in real time and get insight into actually what's happening?
Man, I think, depending on, let's just start here. Everything really depends on your budget. First and foremost, everything depends on your budget. But if you're thinking with security in mind, security at the forefront, and you want to build security in early, as you're designing these things, some of the things that you should really take a deeper dive on, think about threat detection, right? Not just monitoring by itself. Some companies literally only do the bare minimum of monitoring, the bare minimum of alerting, right? Think about threat detection, cloud native, services, third-party tools that offer that continuous monitoring, incident response, things of that nature. If you're using a SIEM, right? That security information and event management system, that's something that you could really leverage, right? If you want to take a deeper dive in really analyzing your logs. I think what's really big, in today's world is not just having monitoring, but making sure that it's actually automated, right? Manual monitoring is not 100% sufficient whatsoever, because if, someone were to leave that, was responsible for doing all of this manual monitoring, of a service or groups of services, then essentially those services would go unmonitored if it's, being manually monitored, right? So cloud service providers, they absolutely have monitoring capabilities, in place. If you're leveraging a CSP within your environment, things that you typically want to see, right? To make sure that you're monitoring for those workloads, system performance, resource utilization, any potential issues that you probably can't visibly see. Those things would basically populate for you on the back end, right? You need that visibility. So automated monitoring is something that should absolutely be considered over manual monitoring. I know you mentioned something about real-time alerting, right? You can absolutely do this if you have predefined thresholds, in place. If you don't have those in place, it's going to be a little bit difficult for you to actually identify any potential anomalies that are detected. Notifications can be set up anywhere. You see a lot, with people blogging about SNS, right? Things of that nature with AWS. PagerDuty is really big now. I have experience with, ServiceNow. These are all essential tools that you can use to set up those real-time alerts So if something happens to that service, or there's a disruption on the back end, or there's some type of incident that's going on, you want to make sure that you actually have real-time alerting in place. We're not talking about, a service or a system that provides you with an alert like every 30 minutes or something like that. No, we're talking about literally as the incident is taking place. That is what's considered real-time alerting. Those are things that you actually want to have in place. Splunk is, another good tool that you can use if you're trying to get into log aggregation. You want to take a deeper analysis into those things. You hear me talking about AWS a lot because, I've used AWS heavily in the past, still do. CloudWatch is something that is major for a lot of organizations, to use, just to take a deeper dive into looking at like patterns and detecting security threats, troubleshooting issues, things of that nature. You have so many tools that are absolutely available to you, and for many of them at a very low cost. It really depends on, going back to that keyword, the way they are configured, right? And I know that cost, is definitely something that's considered whenever you're building these things out. But if you want to have real-time monitoring and alerting in place, consider automated monitoring. Think about services or tools that can provide you with real-time alerts, not anything that's actually going to be delayed or anything of that nature.
We're seeing, obviously, right now when we're recording this, all the buzz is AI this, AI that. On that note, so for organizations that still have that 1800s budget, but they're scared to death of the cloud, they're like, oh my gosh, give me my castle and moat back in the olden days in the 1800s. But the reality is they can't, because they need to remain competitive. They need to push stuff out in the cloud environments. What security measures / resilience recommendations would you have for any organization and so kind of a broad question, to help them protect against some of those emerging threats that we're seeing now, and we're also going to be seeing obviously more of as artificial intelligence is leveraged by threat actors?
That's an excellent question. I think if you're not consistently, testing your services, performing like failure testing or chaos testing, whatever you want to call it, I think that's probably the easiest way for you to determine if you truly have built and designed, resilient, highly available, and secure architecture, right? These things really help you with identifying those potential vulnerabilities and the weaknesses within those applications. Configuration is major when it comes to the cloud, just period. Even for a legacy system, right? Having proper configuration in place is major. If you're running chaos tests, to simulate certain types of scenarios, right? Then think about what Netflix did with like Chaos Monkey, right? Really just changed the game, and how you're literally trying to introduce these failures to get a true observation, of that service or that application's behavior. If you're not consistently testing these services that you're building before you actually deploy them into production, then you're not going to have any idea of how to sufficiently recover that service if there were to be some sort of, disaster or something like that. This is where, again, disaster recovery planning comes in, and you talk about defining your recovery time objectives, your recovery point objectives. You should know, the acceptable downtime that you can afford, your data loss limitations, things of that nature are things that you absolutely should consider when you're building these things out. But if you have not introduced any sort of testing, within your environment, then you're absolutely in trouble. You can also do load testing, right? A lot of people don't think about load testing, but it provides a lot of value, especially for applications that are customer facing, right? You want to make sure that if a failure or something were to take place and you have customers that are trying to visit, let's just say like an e-commerce website, if I'm introducing failure, to that particular application, then, if I'm not getting on my end after I run that test, like server code of 200, then I know that it's probably an issue. If I'm getting anything other than 200, then there's a problem with that load testing that I've actually just implemented for this particular customer facing application. But it's absolutely essential for those applications in which you have, a ton of, customer traffic or users visiting certain website and whatnot like that. Workload distribution is something that you should also consider, right? And this is all about scalability. Again, going back to that, if you don't keep these things in mind as you're designing and building out these architectures, then you're going to have a lot of problems. Talk about disaster recovery. That leads me to replication, backups, snapshots. Where are you storing your data, right? You have to find ways to fully reduce the risk of data loss across the organization. And that also contributes to overall data availability, right? These are things that you should be considering. And it's way more than that. I'm just keeping it high level with things that you can do to really protect yourself, against some of these potential threats, right? And it's all about ensuring that you're maintaining that high availability and that you're able to quickly recover from these failures. But if you're not even testing the services that you're building, you already have a problem. There's no way that you would know if these services truly have, vulnerabilities, or if they're false positives, or if you've really designed a service or application to sustain, certain attacks.
So any final thoughts, wisdom / advice for organizations out there that might be listening or need some help around and or resilience and or security for the organizations, just so they can help position themselves a lot better? Any final thoughts around that for them?
Absolutely. Something that's really big, something that I think organizations completely overlook. And when I say completely overlook, let's just think about what was his name? Edward Snowden, right? Edward Snowden, NSA, stole all of that data. Oh, now he's in Russia having a ball. Whatever the case may be. Think about these measures that potentially were not in place, right? Your RBAC rules, right? That's role-based access control. Did you actually consider least privilege? That's something that you absolutely should consider to protect yourself from all of these emerging, cybersecurity threats. Network security. We talked about that, issue with Capital One, what they didn't actually have in place, right? With the firewalls that were improperly configured. We know that resources weren't actually isolated. The security groups weren't properly configured to facilitate or better help monitor and control that inbound and outbound, traffic. Something else that's really, really big, and this is something that, organizations should consider, especially for those that are really diving into like containerized workloads. If you're using Docker, right, set up your own private internal registry. Don't just use anything that you find, off of Docker Hub and just pull those images that, sure, they've been tested, they've been verified. Yeah, they have the official, Docker tag, but as a best practice, you want to build out these Docker images, right, internally, and make sure that they're actually encrypted, right? A lot of people don't think about that. When you're designing these things, especially if it's going to be something that hundreds or thousands of services could be using within your organization, if you're moving to containerized workloads, literally consider building out your own internal private registry for these images that, you essentially would be hosting, and make sure they're actually encrypted, right? Serverless computing. This is something that could also be beneficial. Take your hands off the keyboard. Configure a service like Lambda to do these things for you, right? Cron jobs, I think, is something that is beneficial. A lot of people don't like those, but cron jobs can do a lot of work for you, right? Properly configure them. They do a lot of the work for you. I know you spoke about AI. Here's something to consider too for organizations that may be on the cheap side, or those that actually don't have, the budget to actually implement a lot of these things. The way that AI has been set up these days, whether you're using ChatGPT or another type of, AI or, machine learning technology, a lot of these failures and whatnot that are taking place, a lot of these threats that are happening, ransomware attacks, AI is essentially able to predict a lot of these failures, right? It's really proactive remediation when you think about it, because it can literally tell you based off of, I guess, the information that you input into the tool itself. It'll tell you how you can automate, the resiliency of these services that you're implemented, ways that you can proactively detect anomalies. AI does that for you. If you're just cheap, or again, you don't have the budget to do that, put the scenario in there. What if XYZ happened? How should I, set up this application? What should the security controls around this application be? How should the pipeline be configured for this application? AI would essentially do a lot of the thinking for you, and you just basically have to really design it and fully build it out. But it'll do all of that, for you, and find a way for you to automate, your resilience around these services. It is possible. I've seen some things personally, and then, think about having immutable infrastructure. People don't think about that, right? They don't think about it. Treating your infrastructure as if it's disposable. You want to deploy new instances instead of making changes to things that already exist, right? You don't have to consider rollbacks in most cases. You don't have to rely upon like configuration drift. That's something that's pretty big with like Terraform. You're thinking about that. And that also is something that drives the improvement of overall system resilience, right? You have to learn to adopt a lot of things like robust monitoring, scalability, redundancy for like your storage. I don't know if we talked about that, but that was something that I wanted to get into too, right? Storage is really huge as well, right? We talked about the replication, the backups and things of that nature, but build these things out with security in mind. Think about all of these cyber threats that are constantly happening, the way that these, threat actors are finding ways to manipulate themselves into your internal services. What are your real life capabilities? Do you actually have anything proactively in place, right, to monitor the performance of these services? Are you really triggering alerts the way that you should? Do you have predefined thresholds in place? A lot of times you don't. It's a lot of tools that's available out there, man, that you can use, like New Relic, right? Dynatrace, Datadog, Prometheus. That's super, super good, especially if you need something, for a cloud native environment. Prometheus is usually the go-to, tool for that. It's going to give you that super deep querying that you need, graphing. It integrates with so many things. I know they have the AWS, version of Prometheus, or you can use standalone Prometheus service. That's also something that's super scalable, right? And it's proactive monitoring for you. So a lot of tools out there that does a lot of this stuff for you. You just have to pre-configure it, based on your internal baseline security configurations, policies, and things of that nature. It's a lot that you can do to become more resilient. But again, it goes back to first understanding and designing your architecture. Are you going to have a monolithic approach? Are you going to use microservices, right? Which one are you more focused on? Based on that, that's going to basically determine your path forward to achieving the resiliency that you truly desire across your service fleet.
Thanks for listening to the show. If you're looking to secure your business better or build up your cybersecurity career, then check us out over at cyberlife.tv. That's CYBERLIFE.tv.